Welcome to the ET335 Inverted Logic Syncing, Sourcing, and Schmitt Triggers Lab, Part B, where we're going to do it in multi-sim, and I am going to cover our Schmitt triggers. Okay, welcome back to our multi-sim. We're going to do the very last one, and that is going to be a Schmitt trigger. And a Schmitt trigger gate is different than a regular gate. So let's go ahead and pull up our Schmitt trigger. So we have a TTL, and for some reason we don't have an LS model, so we're going to go to a 7414 standard. Okay, and we're going to go ahead and grab it and cancel out of it, and let's make it larger here. So let's go to view, and let's zoom area, and let's make it bigger because I still need to bring some things in. There he is, and you notice the symbol in between here. That's a Schmitt trigger, and a Schmitt trigger is used to straighten up and make the square waves nice and straight. It also has two thresholds, a positive going and a negative going threshold. That allows us to eliminate noise from our circuits because of switch bounce or whatever. So we're going to take a good look at that guy and his characteristics. So the first thing we need to do is let's go get our standard Tektronix oscilloscope, and let's get our function generator, and we're just going to use the standard one here, and let's go grab some grounds. And let's grab another one, and hopefully that one attached. Good. Let's close out of that, and let's drag it down and see if it, yes. Okay, so we're going to use the positive coming out of our function generator, and we're going to go ahead and put him in 2, and we're going to take this one and connect it directly into our output. Okay. Let's move that over and let's see if I can make it a little bigger. Good. Okay, so let's go ahead and open up our function generator. We're going to go to sine wave. We're going to 5 kilohertz. And we're going to go to 1.5 volts peak. And we're going to go to 1.5 volts DC offset. And that's going to get us a sine wave that goes from 0 to plus 3 volts. Okay, so let's fire this up. Get him out of the way. Open up our Tektronix scope, turn them on. There we are. Get rid of that. Okay, so first thing we do always is we open up our time base. Good. And that's fine for now, so let's turn on channel 2. And we both have them at 1 volt. That's perfect. So let's go ahead and single, and that's good. So what we have here is our 0 to 3 volts sine wave. Okay, going from 0 to 3. What we have here is the output of our Schmitt trigger, and you can see when it crosses, there's one threshold. There's the other one. So this guy would be the positive going, that would probably be the negative, actually be the other way around. So let's go ahead and open up cursors, and we're going to go to voltage. Good. And both of these, doesn't matter channel 1 or channel 2 because they're the same voltage. Okay, so we see the green LED, so let's figure out which direction this one is coming from the bottom. So, oops. And we're going to where it crosses, and where they cross. So where the blue crosses the yellow, or sine wave crosses our TTL output. And you notice how square that that is coming off a sine wave. So we just converted a sine wave into a square wave. It's a little offset because of the high and low thresholds, but it is nice and square. So let's take a look at our numbers. So we have our lower threshold at 1.2 volts and our upper at 2.2 volts. Okay, we see that we have two. The problem is these are incorrect. They're about half this voltage. Okay, and if we look at the data sheet, uh, these aren't correct, but it does show the thresholds. I tried to monkey with the PSpice. PSpice is the language electrical engineers use to simulate ICs and circuits. This didn't let me get in there, and so obviously they've said it. So a lot of these experiments we use with live devices won't necessarily work with multisim, but we see that we have the two different thresholds compared to the single for a regular gate.